Hey everyone, today we are going to solve the LeetCode question leaf similar trees. Okay, so key point to solve this question is that how can we know if current node is leaf or not? Actually, it's very simple. So leaf node doesn't have any children like left and right. So condition is if not node dot left and not node with node dot right. So if we meet this condition, now we have leaf node, and so we need to keep current node. So here is the idea. So initialized leaves 1 and leaves 2, and they are list. So when we traverse root 1, so we update leaf 1 when we find a leaf node, and when we traverse root 2, so update the leaves 2 when we find a leaf node. So if we meet this condition, update these two list, and in the end, so these two lists will have like a 6, 7, 4, 9, 8, 6, 7, 4, and 9, 8, right? From this example. And then if these lists are same, we should return true. If not, we should return false. So that is our main point. Okay, so let's write the code. First of all, leaves 1 equal empty list, and leaves 2 empty list, and depth first search, and root 1, and leaves 1, and I copy this, and we have 2 tree, right? Root 2 and leaves 2. And then after that, return leaves 1 equal leaves 2. So if they are same, we should return true. If not, we should return false. And let's create a depth first search as an inner function. So dfs, and taking a node and leaves. So first of all, this is a base case. If not node, in that case, we don't do anything, just return. If not the case, here is a point. So if not node left and not node dot right. So in that case, current node is leaf node. So append the current value to leaves dot append and then node dot val. And then so in this case, we don't have to go further, right? Because we already found a leaf node. So that's why we can return here. I think if we don't put return here, we can pass all test cases. But this return makes this program faster, I believe. And then after that, call depth first search and go to left and right. So node.left and leaves. And then I copy this and node.right. Yeah, that's it. So let me submit it. Looks good. And the time complexity of this solution should be order of n1 plus n2. So n1 is number of nodes in the root 1, and n2 is number of nodes in root 2. And the space complexity is order of height of root 1 plus height of root 2 plus, so we use leaves 1 and leaves 2, and the number of data in them, let's say k, so plus k1 plus k2. Yeah, so that's all I have for you today. If you like it, please subscribe to the channel, hit the like button, or leave a comment. I'll see you in the next question.